Canva is an online graphics and video editing platform. It was founded by Milene Perkins in 2007. We chose to build a clone of Canva because of the challenges of a web-based graphic editors. It requires interaction with the DOM, HTML canvas, and JavaScript, apart from traditional front-end tasks like routing and state management. The app we are going to build will in no way be close to the actual Canva editor, but we'll learn all the techniques required to build a JS application of all types. The tiny Canva app will be a single-page application with support for authentication using Firebase Auth, authorization using public and private routes, a create, read, update and delete UI integrated with Firebase Real-Time DB, and a graphics editor built using Fabric.js, a wrapper for HTML5 canvas. In terms of the implementation, we will use Reagent, a CLJS wrapper for React. We will learn how to manage state locally and globally using reactive atoms and reframe. Reactive atoms is Reagent's built-in solution for local state, and reframe is a Flux-like library for Clojure script. For routing, we will stick to traditional React Router 4. This mix showcases the power of Clojure in various conditions, like consuming JS libraries and integrating with React. In the process of building this app, we'll learn more about Clojure's dev workflow, its API, tar edit, and the REPL. In the end, we will learn about advanced concepts like code splitting, production bundles, and unit testing. Here's a preview of what you can expect. We will have a login screen with error management that is connected to Firebase Auth. Once you log in, you will be presented with a dashboard where you can create new graphics and delete existing graphics. You can also log out. Our editor will have the ability to add shapes, multiple types of text, and change the background color of the canvas. It will also allow us to export PNGs or SVGs or save the editor state to Firebase DB. We will also create options to edit individual element properties like width, height, color, etc. By the end of this module, you will have a fully functional application. You'll also have practical experience about how things fit in. We hope that the app built in this module will serve as a starting point for your own Clojure projects. We have already learned how to set up shadow projects manually. We have also used First Project for code examples in the last module. Unlike First Project, Tiny Canva will run in the browser instead of Node terminal. So, in order to get the REPL working, we will need to open the app in a browser in place of running Node script in the shell. Starting with this chapter, we request you to follow along with the lesson text. The videos will give you an overview of the steps and explain new concepts, but the actual build process is text only. In this chapter, we will set up a new shadow project, learn about Hiccup and the required syntax, and ultimately start the dev REPL. You can use Create CLJS app to scaffold a new project. Once your project is ready, open it up in an editor of your choice so we can study the configuration. By default, we have 4 builds, a development server configured to run on port 3000, serving contents from the public directory, an NREPL server configured on port 3333, and 1 source path SRC. We also have 2 dependencies that we will learn about in detail soon. Reagent is a minimalist Clojure wrapper for React, and DevCrud is a storybook-like tool for developing components in isolation. As of now, we should only be concerned with the app build target. The app is configured to call app.core/main function on startup. It targets the browser runtime and spits the compiled JavaScript code to public/JS folder. Let's check the main function definition. As we learned before, the function defined as initfn is called as soon as the app is ready. The generated app.core namespace might look a little different from the namespaces and functions we have defined so far. The NS definition accepts a documentation string, just like function definition. The require form can be passed to NS definition along with vectors of namespaces needed. We load reagent core namespace and alias it as R, and then the app hello namespace. App.hello is defined in src app hello.cljs. This namespace holds the definition for the hello function. This function was generated by create CLJS app and is the reagent version of a functional component. Like React uses JSX to define components, reagent uses Hiccup. Hiccup and JSX can be translated seamlessly. Element open and close tags are replaced with vectors, and props are replaced with prop maps. All we need to know right now is that the app.code/main function is the entry point of this app. Third parties library define their custom namespaces that you can require. In the example above, we required reagent core. There are multiple ways to do so. The simplest way is to just require the namespace. For example, if we require foo_bar, any variable or function defined in this namespace will be available to the namespace where you required it as foo.bar/bars. Typing the entire namespace might be cumbersome, so you can define aliases too, like we did with reagent core. This can be achieved using the as form. It is also possible to require only a subset of the namespace. For example, if we want just the bars definition from foo.bar namespace, you can use the refer keyword. The refer and the as keyword can be used in conjunction as well. Shadow provides us with two special require forms that helps interoperate with npm. We can require npm package as npm package. Notice the string around the first form. And we can also refer to parts of the package using the refer keyword. To require parts of a Clojure namespace with refer keyword, we use square brackets. But to require parts of a package from an npm package, we use parentheses. The main function is familiar to what we have learned so far. It interrupts with JavaScript to find DOM element with ID app and then calls reagents render method with DOM element and the hello component. The *div afterload denotes metadata attached to a function. In this case, the metadata is to let Shadow know that the render function should be called each time the app is hot reloaded. Div afterload keyword is a Shadow lifecycle hook. During production compilation, Shadow minifies and uglifies your code. Uglification renames variables and function definitions. But we need the main function to stay intact, so it can be called when the app loads. Functions marked with export are not uglified or renamed. Create CLJS app creates a sane package JSON as well. It adds React as a dependency and also defines scripts to run, test and package the application. You can inspect package JSON and analyze all scripts. But for now, we only care about the start and the build script. Start starts the application in dev mode and build compiles the application in production mode. Our first project was a Node script and could be executed in a terminal. But the code produced via browser target needs a web browser to run. The public directory contains files that will be served to a browser via a development server. The index.html file loads the compiled script. It also defines a div with ID of app, which is used by render function to render the React application. The public directory also has a top-level style sheet. Other assets like fonts, images, etc. can also be placed here. The Bootstrap project has some other files related to testing as well, but we will explore them later. For now, we can jump straight to starting our app using yarn start. After the build is completed, you would see a React component running on localhost 3000. In this chapter, we created a React reagent application using create CLJS app. We walked through some components that were automatically generated and started the application. We also saw how defin can be used with metadata and learnt about hiccup and require forms.